Okay, today's lesson is going to be about finding the distance. So right at the top of this, finding distance, underline distance, so you know when you look at this worksheet, this is what we were talking about, distance. If I want to find the distance between two things, for example, if I want to find the distance between me and the door, what am I going to do? Measure it using what? Some sort of units, inches, feet, probably on a tape measure, right? Could I just walk and count my steps? Would that be a measurement? If I said it's 50 steps? Yeah, that's a measurement. So you can measure things in a lot of different ways, but you're going to use it, you're going to measure it using some kind of units. Now on a graph, the best way to measure something is to count your blocks as units, right? So from this point to this point would be one whole unit, or one, you could even think of it as a step. Okay, so first thing that we're going to do is we're going to graph our 2 points. We've got point A and point B. If you graph these wrong, you will get the wrong answer. So keep in mind that that's the first step, is making sure you put them where they go. So I'm going to zoom in here. If my first point is at -5, 1, if my first point is at -5, 1, so my first number is my x, and my second number is my y. So I'm going to start, and I'm going to go on the x-axis to -5, and then I'm going to go up to 1, and this would be point A, right? Y'all plot this. Put point A on your paper. Okay, for point B, 2, 1, I'm going to go over to 2, and then I'm going to go up to 1. So this is point B. Now you do not have to connect them, but I'm going to. It doesn't hurt. Because what you're looking at is basically just a little line segment. If I wanted to figure out the distance from point A to point B, what would I do? Count the boxes. Now, make sure you pay attention to this. You wouldn't believe how many people count this wrong. Okay? I have people that would start here and say, okay, 1, 2, 3. There's a problem with that. When you're starting, if I'm not moving, do I count 1? You don't count 1 step until you actually take a step, right? So right now, I'm at 0. So from here to hit this point would be 1, 2, 3, 4, 5, 6, 7. So this segment, or this distance, would be 7 units long. Easy. Piece of cake. What this means is that segment AB is 7 units long. This little symbol right here just means segment. How hard is that? Can we all count? Hello, are you guys awake? Can we all count? Counting's pretty easy. All right, let's look at example 2. First thing I'm going to do is I'm going to plot point M. I'm going to go to 1, 4. So first I go to 1 on the x-axis and then up to 4. This is point M. And then I'm going to go to N, which is at 1, -3. 1, 2, 3. And I want to know how long is this segment. Can I count? Anytime you are literally on top of a line, you can count. So I'm going to count from M down. And again, do not start counting 1 here. This is not 1. You have not moved anywhere. 1, 2, 3, 4, 5, 6, 7 again. So this is also 7 units. Okay, so first thing, when you are told to find distance, if you have a horizontal line or a vertical line, just count. And any one of us can count. The problem is all points are not going to be straight across from each other like this or like this. They might be diagonal from each other. Okay, so let's look at example 3. All right, example 3. So first thing let's plot point T. So I'm going to go -2 and then -3. That's my first point, T. And then V is at 0, 3. All right, there's one with a 0 in it. If my first number is 0, do I move? No. If my second number is 3, you go up to 3. So here I've got a little segment. And I want to know how long that segment is. First question, is this a horizontal or a vertical line? Yep. Horizontal would mean like this one up here. And then vertical would mean like this one right here. This is not horizontal or vertical, okay? When this happens, you cannot count this, okay? And I've got so many kids who are going to try to do this. You cannot count whenever it's diagonal at all, okay? So here is where we have to do something a little bit different. Do you guys have any suggestions? How I might find the distance from T to V? No suggestions? All right, let me give you the best way to do this. There's something called the distance formula. We're not going to do that. It's complicated. The best way to do this is to make this, turn this into a triangle by going over and up. What kind of triangle is that? That's a right triangle, because this right here would be a right angle. Now the good thing about this is, can I count this segment? How long is this segment? 2 units, right? That one's easy to count. That one's 2. Can I count this segment? If it's straight up and down, yeah, you can count it. So let's see. This segment is 1, 2, 3, 4, 5, 6 units long. Well, guess what? I got a right triangle. I know this segment is 2 units and this segment is 6 units. Would this not be my hypotenuse? Yes? Would this not be C? Are y'all with me? Y'all see what I'm hitting at? So this would be A and this would be B, and now I can do the Pythagorean theorem. So the good news is this is really easy. You guys know how to do this. Let's say A is 2 and let's say B is 6, and we're looking for C. Y'all remember how to do this? What do I do with this? Yeah, 2 squared plus 6 squared. You type that in the calculator, see what that gives you. That's why I told you guys to have your calculators. 40. All right. So all of this gives us 40, which this segment is not 40 units long. We always have to do one last thing when we're doing the Pythagorean theorem. What's the last step? Square root, right? And so somebody see what the square root of 40 is. 6.32. Boom. So what that means is this segment from T to V is about 6.32 units long. Anytime you have a line that is not straight up and down or not horizontal, you have to do this if you want to know how long it is. The good news is we all know how to do the Pythagorean theorem, so there's nothing to this. The hardest part is counting correctly. You wouldn't believe how many people miss that. Okay, so I put 6.32 units up there. That's how long this segment is. All right, let's look at example 4. We're going to do this one together, and then you guys are going to do a couple by yourself. So first thing is get your point in the right spot. -3, +3. So first I'm going to go to -3, and then I'm going to go up to +3. That's x. Then I need to do y. So first thing is, if 1 is my first number, I need to go over to 1. And then if my second number is 0, what do? Do I go up or down any? No, stay put. That right there is y. So we want to know how long is this segment. Now, unless I ask for an estimate, there's no way to just guess what this is. So when this happens, you draw in a right triangle. The best thing to do would be to go, you always have to go straight down and straight over. So here's my right angle. Now, how long is this segment right here? This one's 3. How long is the bottom one? 4. So that means this one over here is going to be C. Spoiler alert, the one that we're looking for is always going to be C. Okay, because you're always going to go down and over. All right, so all we got to do is fill in the formula. I'm going to say A is 3, and I'm going to say B is 4, and we're looking for C. All right. So we're going to type that into the calculator. We get 25. And what do we do with 25? Square root it. Anybody know what that one is? 5. So that means this segment here is 5 units long. Is this easy or what? It's easy because you only have to know how to count and do the Pythagorean theorem. Both of those things we know how to do. Okay, let's look at the back. The only difference between this is my graphs go to 10, but you do this the same way. Okay, so I'm going to give you guys a couple of seconds. I want you to do example 5. You're going to put the points on the graph and then figure out how long that segment is. And then same thing with number 6. All right, something I just noticed on this graph, or on these bigger graphs, is that the numbers aren't exactly in the right spots. Did you guys notice that? Like on this, they're good. This is 1, 2, 3, 4, 5, 6, and so forth. They're okay here. 1, 2, 3, 4, 5. They're a little off. But on this bottom section, I don't know if y'all can tell this, but -1, the first line is actually right here. We're literally in these numbers. So that should be -1. And then -2 would be here. And then -3 would be here. And -4 would be there. So you see the numbers are a little bit in the wrong spot. Maybe that might have messed you up. Maybe it didn't. We'll see. Okay, so for example 5, the first point is -8, -3. That would be here. The second point is at +3, -3. So when this happens, when it's a horizontal line, I can just count that, right? I've had people try to draw triangles out of this. There's no point. It's just a straight line. Count it. And when you count it, you should count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you counted 12 or 13 or 10, you miscounted. Okay, good? All right, let's look at the second. For point P, we're going to go to 2, -7, which hopefully -7 is right here on the graph, but the line is actually up above it. That is P. For G, we're going to go to 5, 6. That would be there. So in this case, we are going to have to draw a triangle. So I would go over, and how far over do I go? Until you line up with G. All right, so how long is this segment? 3. And then this one would be 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. Did any of you guys count 12? Or 14? Yeah, and it's because you put this point lower than it was supposed to go, but that's because of the numbers. Okay, don't worry about changing it. It's just these numbers are in a weird spot. All right, so, but it should have been 3 this direction and then 13 this direction. So I'm going to do 3 squared plus 13 squared equals C squared. That gives me 178, and then when I square root that, you get 13.34. So that means this segment PG is 13.34 units long. Again, most important part is making the points go where they belong. Even on a graph like this where it's confusing, I need to make sure everybody sees this. Do y'all see this? That these numbers are kind of in the wrong spot. They're lower than they really need to be. -1 is actually right here. This one would be -2, and so forth. But anyways, most of the graphs are probably going to be smaller like these on the front. Questions?